Good morning class. Welcome to the online classes for physics of class 9. As we have started our new chapter, that is work and energy. I think in the previous videos you may have seen this video also. We have gone through the introduction to that, what is work done, how it is defined, and how does it shows that how it depends on the displacement, right? So what was the work done? That if we apply a external force on any body, we have seen that force is the main thing that which allows the body to move. That is, force is a thing which allows the body to be in the motion. So to move any body, force is the required part. So force, when it is applied on any body, the body starts moving. Now what that moving means, it will not continuous move now, so it just displaces from one point to another point. So what we can say, that on applying the force on any body, there will be some displacement on that body. Like if you want to displace a table behind you, then what you will do, you will apply a force on it and that table will move. So now when you apply the force on any body, the body starts moving, that it will start displaced. So when it gets displaced, then we can say that there is a change in the position of that body. Like if you are holding a ball, then you are just displacing it from the top of the table to that of the top of the other one's table. Like someone is asking, your friend is asking your ball, then what you will do, then you will be taking your ball from your table to that and give it to them on its table. So what will happen, that the ball is displaced from our table to that person's table. So now body's positions are changed. So this change in the position can also be defined as a displacement. So when the force is applied on any body, there is the change in the position due to which the body gets displaced, and these displacement due to that force is said to be work done. That means if you are doing any work, then force is the necessary thing that is required to move any object, and the body should be displaced, then only the body can be said to be doing work. So work is said to be done only when the body is displaced, and that too due to the applied external force. So what the work done can be given as, it can given as work done equals to force into displacement, and displacement is given with the letter S. And what was the unit for it? If we talk about SI unit, force is given as Newton and displacement is given as meter, so it is Newton meter. If we talk about CGS unit, then it will be Dine centimeter, right? But together, taking this Newton meter or Dine centimeter, we can write it as joules. So it will be considered as joules. So work done's unit, that is the unit for the work done, will be given as joule, and this unit can also be given as ergs also. So this will be the SI unit for it, and this will be the CGS unit. Like this Newton and meter together, it will give as joules, and Dine centimeter together, it will give as ergs. And we can convert that one unit to that of the other. Like if we convert a SI unit like meter into the centimeter, we used to multiply it to 100, that is 10 to the power 2 is multiplied. If we are just converting a kgs to the grams or kilometers to meters, we are used to multiply with 1000, that is we are multiplying it to 10 to the power 3. So this is what the change in the units. Like if we are converting it to SI unit to that to the CGS unit, then we used to multiply with some letters, that are numerical values. So here also we can convert joules into ergs by multiplying some numerical value, and that numerical value here is 10 to the power 7. So if we multiply 10 to the power 7, so we can convert it into joules to ergs. So what we can write it as, like 1 joule equals to 10 to the power 7 ergs. Okay, so ergs and joule both are the units of the work. Okay, so now this force, when it applies, it will move in some direction, right? We apply a force in different directions. So if we consider a single direction that you are applying, like if you are pushing a door or pulling a door, so you know what a direction of your force is, right? When you pull the door, then the force is towards you, right? You are trying to show the direction towards you, then the body will be moving towards behind you, that is the door will move towards you. So force is in the direction of you. And if you want to push the door, then what you will do, then you are trying to give the force in the direction opposite to you. So whenever you apply the force, the body will also displace in the same direction, right? So if you apply the force, the body cannot displace in this direction, right? If you want to push, it cannot be behind you, it cannot come behind, right? You otherwise you will be fall down. That means what? That if you are applying the force and the work or that displacement is in the negative direction, so the work done will be also negative, so you will get a negative impact, like you will fall down or it will come on us, right? So this is what the kind of the force and the displacement's direction show us. So force and displacement should be in the same direction itself, it cannot be in the different directions, right? Force and displacement should be in that, should be means that is in an ideal condition, and if it happens then only the work is said to be done in the positive way. Okay, so work is said to be done only when the force is applied on the body and the body get displaced, that it changes its position from one point to the other point, right? And the force and the displacement, when you apply any force, it will get displaced in the direction in which you have applied the force. So both will have the same directions. When applying these directions, this is kind of push and the pull, but here we can just apply the stretch also, because we already have learned that force can be of different actions like stretching, compressing, loading, or you are just carrying any body, so lifting, pulling. So different actions, these compressions and all different actions will be considered as a force itself. So similarly, so pushing and pulling were taken as these directions, but if you want to rotate any object, there also we are having some force, but here the direction will depend on the accelerating motion, that how you are trying to accelerate that body, right? Continuous you are changing its velocity, so it's accelerating, so body will get accelerated continuously, so its velocity is continuously changing, right? So work done is kind of a thing which depends on the force and the displacement. So either force will be there on the body or the work done will be there. Otherwise, if displacement is there, then only the work done is there. If any of the value gets 0, that if its force is 0, then work done given as force into displacement, so 0 into S will be 0. If you take S as 0, then also the body's condition will be 0. So whether the body did not get displaced or the force is not applied on any body, then the work is said to be not to be done, because at that time the numerical value of the work done is 0. So if any of the value, that is either the force or the displacement, gets zeros, then the work done will also be 0. So there is no work done by the person or by the system, right? So now without the direction, if you are inclining with an angle and taking that body, so what it will be considered as, like if you are trying to pull any body, you know that if you are having a normal car, if you are having this car and you want to try to pull it, so what you will do, you will pull it, so you will try to pull it and you will be moving it in your direction, whatever you want to, wherever you want. If you want to pull in this direction, the rope will be that side. In childhood times we used to play with it, right? So tying any thread or the rope to that toy which you want to displace, we used to pull it in the direction where you want to displace, because force and displacement used to be in the same direction. So this is what the inclination, this inclination of the force is given with the theta, that is whatever the angle you are having with the rope. Here the rope is the situation, but otherwise you can take your hand also. So whatever the angle with which you are trying to displace that object is taken as theta. So this theta is showing an angle. This you will be studying again in class 10th in maths, so that time you will be more clear with it, but just understand this how we are taking these values, right? So theta is just an angle between that force and the body's displacement. So these theta, whatever value we are taking, theta is just an angle, so angle can be of 30, 45, 60, 90, 180, so different angles we already know. So whatever the angle we are taking, the work done will supposed to be depend on that angle itself. So with what angle we are trying to move, or what angle which we are trying to move, give the force on that body, it will depend the work done also. So when theta equals to 0 degree, what that means, that you are not having any angle between you and the force. So you are not taking any angle, and with the 0 degree you want to try to push or pull any object, like if you want to apply the force without any angle. So whether the work done will be easy? No, right? It will be not that much easy. So with any angle we should apply the force. So if you are not applying any angle, that is you are not applying any force along with the angle, you are just trying to push or pull, like if you are sleeping and giving you a bottle, how can you just displace it, right? With your hand you should move it with an angle. So if the angle is not there, what the value will be? See, when we are taking force into displacement. Work done is given as force into displacement. But here together an orientation came which is given as cos theta. So this is a new value which you can see. This is a mathematical value cos theta. This is a type of an angle and it have different values also. This you will be seeing in class 10 maths also. That time you will be more clear with this word. So cos theta. So theta will vary. If you take theta equals to 0 degree, remember that cos 0 degree is taken as 1. So Fs here you take as cos 0 degree. So what the value will be? 1. So Fs into 1 will be Fs itself. That means if you do not put any angle or there is no angle between you and the displacement along with the force, that means the body's work done will be the maximum work done because it is given as Fs and this is only the work done. So there is no difference when you take with an angle. Without any angle you are doing that work, that means the work will be the maximum work done by you. Okay, but if you take this theta as 90 degree, so like if you are trying to pull any object straight or you are trying to put that object on your head, like you are used to load your luggages on your head, right? You try to pull that object totally from the downward to that to the on the head. That means in the 90 degree you are doing that work, putting that force and keeping that object along with the 90 degree orientation. Means between the force and the displacement there is an angle of 90 degree. So now the theta's value will be 90 degree. So again work done's value will change. Now in this place cos theta it will be cos 90 and cos 90 degree gives as 0. So value is 0. So f into s into 0 will be 0. So work done is 0. Here in this condition if you take 90 degree orientation to pull any object, at that time the value becomes minimum. That work done will be minimum. If theta equals to 60 degree, like you are trying to tying a rope with a car or any toy and you are trying to pull it, that means you are having an angle of theta equals to 60 degree. So at that time cos 60 is given as 1 by 2, that means half. The value is half. So work done will be half into Fs. That means your work done will be halved. So now your work done is not that much maximum also, not that much minimum also. So if you want to make your work done to minimum condition, like you don't want to work, so you have to do that work by the 90 degree angle. That means you have to take that book or you want to take that luggage, you should put it on your head, then or you can just take it on your head or on the top condition anywhere. So at that time the work done will be taken as 0. If you take an angle of 60 degree with the force and the displacement, then at that time your work done will be taken as half. That means not that much maximum work is done by you or not that much minimum work. So the work done will be taken as half. Similarly, if theta equals to 0, that is no angle is taken between you and the force, then at that time the cos 0 is taken as 1. So force into displacement into 1 will be given as force into displacement itself. So work done will be given as force into displacement. So this is what the values for the different angles or the orientation taken between you and the force, right? So this is what the value for the work done, how it becomes maximum, how it becomes minimum, and how it depends on the values. Now if you take this theta equals to 180 degree, one more is there, that 180, like you are just slipping and trying to move any object, at that time it's 180 degree. So 0 degree also the similar, because 180 and 0 are same but the directions are different. 180 means you are just in the opposite direction to the body to which you want to move. So if bottle is kept over there, your hand is not on that side, your legs are on that side, and if you want to displace that object, and perfectly if you want to displace, you cannot. So negative work will be done, it will be fall down, it will fall, or your water will be failure. So what that time will happen, that you will get a scolding from your parents that the work which you want to do, you should do it properly, right? So now we are taking an angle of 180 that we are doing in the opposite direction. At that time cos 180's value is taken as -1, means work done, that is f into s into -1 is given as -fs. So this work is said as negative work done. This is negative work done. Okay, this is what the negative work done is. So in different conditions we have taken different work done. So first condition, when we have taken theta equals to 0 degree, at that time work done was maximum. So that condition is taken as positive work done. So in this condition you will have just a positive work done in 60 degree also, and in 90 degree condition it is taken as 0 work done. That is, at that time you don't have to do that much work, right? If you put the luggage on your head, you just don't have to move your body more much, you don't have to do the work that much. So work done is now 0 condition. But if you take theta equals to 180, so that time your work will be different, that the work which you want to do, it will be not done, and extra work can also be given by you. So that time the work is at that condition will be considered as a negative work done. So these are the values of the theta by which the work done can be varied. Okay, so work done by the force can be changed, like if you want to have a linear force or a constant force, then what the value which was taken as, I have told you that the force and the displacement should be in the same direction, there is no theta. If you talk about a varying force, then the theta value will also come. Okay, so any values if given you in the numerical, that is force and the displacement together, if you multiply it, then you can get the work done which is given with the unit joule. Similarly, what is energy? That is, if you want to do any work, so what the capacity or how much capacity with which you can complete the work is taken as a energy, but energy is similar to that of the work done itself. So capacity of doing that work is taken as a energy. So it can be defined as that the capacity of doing work is known as a energy, and the unit of energy is given as joule, similar to that of the unit of the work done. So energy possessed by an object is measured in the terms of the capacity of doing that work. So unit of energy is joule itself. So similar, kilojoules can also be taken for the energy, because we are already familiar with the words, that is kilojoules in our daily routines also, that how much energies you are taking, how much joules you are taking, how much kilojoules you are taking. So similarly, energy is given as the capacity of doing any work, and the unit will be same as that of work done. So energy, but it can be of two types. Similar, the mechanical energy, that is the mechanical work done by you. So how much energy is being possessed by you in doing that work is taken as a mechanical energy, and these mechanical energy can be considered as of two types, that is, one is kinetic energy and the other one is taken as a potential energy. Okay, so this kinetic energy and the potential energy will depend on the different patterns. Like kinetic energy, if you are taking, that means the body is in motion, so the energy possessed by the body when it is in motion is taken as kinetic energy. And when you want be in the stationary, like body is in the stationary condition, at that time it is taken as potential energy. What does it mean? Like if you want to stretch any body, if you want to compress any body, lift any body, at that time in this condition the energy possessed by you is taken as a potential energies. There's formulas and different conditions we will be discussing in the next videos. So thank you class. Try to recall this all the topics once again. We will be more discussing about this chapter, and the numericals also will be seen in the next class from your refreshers itself. Okay, so thank you class.